Hello, my name is Paul Osting, and the topic I am presenting on for my final project is can we predict serial ratings? So, for an introduction, some of the topics I'm going to look into are what data are we working with? Is it possible to predict serial ratings? What factors affect rating? What would a model look like to predict the rating? What is the best model that we can have? And what makes it the best model?
Data classification. The data types that we will be working with in our data set are qualitative, quantitative, and ordinal data. Um, the qualitative data is the name, manufacturer, type, and shelf. The quantitative data is the calories, protein, fat, sodium, fiber, complex carbs, sugars, potassium, weight, cups, and rating. And the ordinal data is the vitamins in the cereal. The first visualization of the data that we will look at is a scatterplot matrix. This scatterplot matrix shows histograms of the four variables along with scatterplots of the variables at each intersection of the categories. This can show early indications of relationships between different categories. For example, at the intersection between calories and rating, you can see a moderate negative relationship between the two variables. The next data visual that we will look at is the histogram of serial ratings. The distribution is unimodal with a moderately right skew. It is important to check the histogram of the data that you are working with to see if it is remotely normal and if any extreme outliers are present. The first relationship I wanted to investigate was the relationship between average rating and manufacturer. The highest average rating company is Nabasco with an average rating of 67.97. The lowest average rating company is General Mills with an average rating of 34.49. American Home Food Products is another highly rated company with an average rating of 54.85. The other companies are all closely related or closely rated with average ratings around 42. There is a possible relationship between consumer rating and manufacturer with two standout companies and one underperforming company. The next relationship I wanted to investigate was the relationship between rating and calories. There appears to be a relationship between these two categories. As you can see in the linear regression model on the slide, there is a negative linear relationship between consumer rating and calories. This model is modeled by the equation y equals negative 0.4274x plus 93.555. The R squared of this model is 84.34%. Another relationship that I was interested in was the relationship between the shelf that the product is on in stores and its rating. Since shelf is considered categorical data, it is best to look at this relationship through box plots. Shelves 1 and 3 both have larger medians than shelf 2. Shelves 3 data is skewed to the right, while shelves 1 and 2 aren't skewed at all. All three shelves have an outlier. There does appear to be a relationship between consumer rating and shelf, with shelves 1 and 3 having higher medians than shelves 2. Modeling predicted rating with multiple categories from the data set. This model is shown on the slide. For the hypothesis testing of the model, we are showing that at least one of the betas is not equal to 0. The alpha for the model is equal to 0.01. This means that the f-statistic has to equate to a p-value that is less than 0.01. For this reason, we reject the null hypothesis since our p-value is less than 0.0001. The standard error of the model is equal to 1.40. This means that the model's predictions of serial rating are typically off by about 1.40 rating points on average. The next step was to conduct an exhaustive search of all the models that can be created with the variables that we are using. On the slide, we have all the models and their adjusted R-squared values. The best model by adjusted R-squared is the model that considers calories, fat, fiber, and if the cereal is hot or cold. This best model can be seen on the screen with the betas and the intercepts. along with its R squared, adjusted R squared, and its p-value. Model statistics that comment on the errors of the model are seen on the slide.
Real world takeaways. If you are creating a cereal from scratch and you are trying to make the single best cereal, the categories that need to be optimized are calories, fat, fiber, and if the cereal is hot or cold. 77.59% of the variation in cereal rating can be explained by the former categories.
Thank you for watching.